All right, so corresponding angles. We know if the lines are parallel, then corresponding angles are what? Congruent to one another, right? So that's what the original statement about corresponding angles was. The converse turns it around, right? Remember, the converse just reverses things. So what this says, the corresponding angles converse says that if the angles are congruent, then the lines are parallel. So from our picture here, we would be able to say that what are a pair of corresponding angles here? 1 and 5, 1 and 3 are not corresponding. They're vertical. 1 and 5 are corresponding, or we could use 2 and 6, 4 and 8, 3 and 7. Any of those pairs, okay? So we're just going to use 1 in our example here. So if the first one you guys said was 1 and 5. So if angle 1 is congruent to angle 5, then line L is parallel to line M. That's what the converse of the corresponding angles theorem says.
Okay, so what is that last part? What is that saying?
That says line L is parallel to line M. Okay. And they're just named because we don't have any points named on there, so we named them by the letter that's on it. Line L is parallel to line M out of that. Okay. So if you can get corresponding angles congruent, then the converse of the corresponding angles theorem says that now the lines are parallel. Okay. Next one, alternate interior angles. What do we know about alternate interior angles?
They're congruent.
They're congruent to one another. They're not supplementary. Their alternate interior angles are congruent if the lines are parallel. The converse says if the angles are congruent, then the lines are parallel. So give me a pair of alternating interiors. 4 and 6 or 3 and 5. Either of those two. So if angle 4 is congruent to angle 6, then line L is parallel to line M. The alternate exterior angles. What do we know about alternate exterior? Alternate exteriors are congruent to one another, and if the lines are parallel, the converse turns it around and says if those alternate exterior angles are congruent, then the lines are parallel. So what are a pair of alternate exterior angles? 1 and 7 or 2 and 8. Either of those pairs. So if angle 1 is congruent to angle 7, then line L is parallel to line M. Consecutive interior angles or same side interior are supplementary. We know that means they add up to be what? 180. So what is a pair of consecutive interior angles in this picture? No. 4 and 5 or 3 and 6. Those are the only two. There were several other answers that were floating out there that's not right. So 4 and 5 are consecutive interiors, and 3 and 6 are consecutive interiors. And so if the consecutive interiors are supplementary, then the lines are parallel. So to be supplementary, if the measure of angle 4 and 5 equals 180 degrees, then line L is parallel to line M. What about consecutive exteriors? Same thing. So give me a pair of consecutive exteriors. 1 and 8 or 2 and 7. Either of those. So if the measure of angle 1 plus the measure of angle 8 equals 180 degrees, then line L is parallel to line M. So we're using these converse theorem in order to prove two lines parallel. Okay, so if the lines are already parallel, then that's how we can get angles to be either congruent or supplementary. But if we don't have the lines parallel already, we can prove that they are parallel by using these converse theorems. When we get into the proofs later on, maybe we'll get to them today. We're going to use these as reasons for proving lines parallel, or maybe need that in the middle of it so that we can prove some angles congruent or something like that. All right. Let's do a little bit of work here. We're just going to decide if line L and line M are parallel based on the information that's given in this diagram. If it's yes, they are parallel.
Mr. Isbell?
Yeah.
Will we swear you can check him out, please?
Okay.
Thank you.
All right. And then, so if they are parallel, then we are going to state the converse theorem that gets them there. All right. So what do we know about those two angles there that are listed? I think this is all we're going to get to today. So hope you feel better. All right. They're congruent and they're alternate. Yeah, you need to go. Just go by and wave at Miss Megan. She'll get you checked out. All right. 63 and 63 are alternate exteriors. So this is yes and alternate exterior angles. Converse. Writing converse is important. If you don't put converse on there in your proof, then that's wrong.
How's this different from what we done the other day?
The other day, we already had, they told us that the lines were parallel, and we saw the relationship. The relationship's the same. The difference is because these angles are congruent and they're alternate exteriors, then that proves that those two lines are parallel to each other. Picture looks like they are, but we got to be able to prove it either algebraically or with different theorems and things with geometry. So yeah, it's a lot of the same thing, but it's just backwards. Number two, what do we know about those two angles? They're corresponding, and what does that mark on there mean? They're congruent. That's what that notation there on that picture is saying that these two angles are congruent to one another. That's what that symbol in there means, is those two angles that have that single arc mark are congruent to one another. And so these would be parallel by the corresponding angles, converse. All right. Number three.
Yes, they're consecutive exteriors.
48 plus 132 is 180. So that's consecutive exteriors. So the yes, consecutive exterior angles converse. Number four. No. What are those angles? Vertical angles. Vertical angles does not prove lines parallel. Okay. So big no on that one. Vertical angles could help us get there maybe eventually, but it doesn't. That is not a reason that lines can be parallel. Vertical angles occur. If line L wasn't in there, they'd still be vertical angles, right? So it has nothing to do with the lines being parallel. So be careful of that. That's a very common misconception, is that vertical angles could prove lines parallel. It doesn't. Number five, alternate interiors. Alternate interior angles converse. Number six, 125 plus 165 is 180. No, that doesn't have to be 180. That has to be 190. So this is a big no. The picture looks like they're parallel, right?
Yeah.
Don't go by that. Be careful. They do that on purpose to make sure you're checking all the boxes there. All right. This looks fun. Got a lot of angles, got 16 angles there to deal with, and 2 pairs of lines. It says, given the following information, determine which lines, if any, are parallel, and state the converse that justifies your answer. So each part A is a separate problem from part B. It's not in combination A plus B, or, it's just one problem. So if angle 2 and angle 4 are congruent, what 2 lines become parallel? Angle 2 and 4 are here and here. Those are what kind of angles? Corresponding with what is the transversal? Line A is the transversal, so that's why C and D is the right pair. So C is parallel to D. If you can identify the transversal, it makes it a lot easier to determine when they've got a bunch of lines in the picture. Just make sure you're looking for the transversal there. And then that would be the corresponding angles converse. Okay. Angle 5 is congruent to angle 10. Alternate interiors. What's the transversal? So that means what 2 lines are parallel? A is parallel to B. Alternate interior angles converse.
We have to write it out, or can we like shorten it like that?
You can shorten it like that. C, measure of angle 1 plus the measure of angle 13 is equal to 180. Angle 1
Yes,
and 13. What are those?
they are consecutive exteriors.
Consecutive exteriors. What is the transversal?
It is
C, so that means what 2 lines are parallel?
A and B.
A is parallel to B. Consecutive exterior angles. Okay. Angle 1 is congruent to 14. They're alternate exteriors, so which 2 lines are parallel now? A and B again. Okay. Measure of angle 14 and the measure of angle 15 are not congruent to one another, but they're right there.
But they also don't line.
It says they had to be 180.
No, because they were for, well, no.
Yes, they're consecutive
Consecutive
interiors.
They're consecutive interiors for what 2 lines?
For C and D.
C being parallel to D.
Yes.
And B is your transversal. Is what we're looking at there. So, again, identifying the transversal is going to make you simplify your pictures. I mean, I can just forget A exists. It's not even in the problem. So 14, 15 gets lines C and D parallel, and they're consecutive interior angles. Okay. 11 and 16.
No. The vertical.
They're vertical, so vertical angles don't do anything. So none on that. G, 4 and 15.
They are alternate exteriors.
They're alternate exteriors with what is the transversal? What is the transversal?
D, sorry.
D is the transversal, which means lines what?
A and B.
A is parallel to B, alternate exterior angles. Good. 10 and 12.
They're corresponding.
Corresponding angles with what is the transversal?
D is the transversal to C and D.
D is the transversal C and D are the parallel ones. Good job. All right. Good news. C parallel to D, and then they're corresponding. Okay. I, measure of angle 9 and measure of angle 13. None? Is that what, why? They're a linear pair, not an consecutive interior, consecutive exterior, how of that. So that doesn't help us. So that's a none. Good job. Two and 7. Alternate interiors. C is parallel to D. I did. Oh. Yeah, you should be happy now. All right. Okay. Alternate interior angles. And last one. For this one, 6 and 11. None. They don't share a transversal there. So that's the key on that one. All right. Not bad. Not bad. Good job, guys. Number 8. Example 8. We got a much more complicated picture. 24 angles to deal with. A lot of transversals, a lot of parallel lines. So we're going to try to get a couple of lines parallel with this. So same idea, but we got a little bit more complicated picture. So 9 and 22. Alternate exterior. So what line pair do we have? Q is parallel to R. And yeah, S is the transversal. So 9 and 22 are alternate exteriors. Good job. B. 8. Consecutive interiors. So what two lines are parallel? P and Q. P parallel to Q or Q parallel to P, whichever way you want to. Consecutive interior angles Converse. Good job. 1 and 17 corresponding angles. And so what two lines are parallel? P is parallel to R. So we can imagine that line Q and all the stuff that goes with it doesn't exist in this picture. The transversal is S, 1 and 17 are corresponding there. Okay, 16. Alternate interior over what transversal? T, so that gets us Q and R parallel to one another. Alternate interior angles Converse. Okay. Consecutive exteriors for what two lines? P and R, the transversal being S. That's right. P parallel to R. Consecutive exterior. Good job. 10 and 13. Okay, Q would be the transversal. Yeah, what are they? What would 10 and 13 have to be for that to be a? What kind of angles are 10 and 13? They're consecutive interiors. They're consecutive interiors whether parallel lines exist or not. They're still consecutive interiors, but because they don't add up to be how much? 180. That's what makes them not parallel. Okay, so they are consecutive interiors, but they should add up to be 180, not be congruent to one another. And when y'all said it had to be would have to be perpendicular for that to happen, that's true. You'd have to have two 90-degree angles there to make that happen. So this is we put an X there and wrote none here, didn't we? Okay. 3 and 22. Corresponding is the right one. They're on the same side. And what are our two parallel lines there? P and R with a transversal of S. P parallel to R. Corresponding angles. Converse. All right. 5 and 15. Alternate exterior angles. 5 and 15. And transversal is T. P and Q. Alternate exterior angles. Converse. And then the last one says the measure of angle 2 plus the measure of angle 16 is 180. None, because those two angles do they have any kind of relationship? Do they? They're not on the same transversal, so there's no relationship there with them. If we knew something about some of our other angles, we could probably get around to some sort of thing with that, but we don't know anything about any angles there to get that. All right, so bottom of that page, you got the transitive property of parallel lines. If two lines are parallel to the same line, then they are parallel to each other. So in the statement there, if P is parallel to Q and Q is parallel to R, then P is parallel to R there. So it's the same old transitive property that we've dealt with before. So in this problem, they give us that A is parallel to C. So you could, in the picture, put a little extra arrow on those to say that those two are parallel to one another. State which other lines are parallel and why they are. So by what reason? We got to have a reason. The picture looks like they are, but that doesn't necessarily mean that they are. Because one could be off by just a touch, just 1/10 of a degree angle change, and they look parallel, but they're not. So let's just kind of try to step our way through some stuff and what we know.
B and C would be parallel because 84 and 96 would not add up to 180, so they're consecutive. Nope.
Does it?
They're corresponding.
No,
Never mind then.
they're not corresponding. You were on the right track the right way. They're consecutive exteriors for B and C because 84 and 96 adds to be 180. So consecutive interior angles converse gets B parallel to C by consecutive exterior angles converse. That means A is parallel to B because A was parallel to C. So what does that? Transitive property. Technically, it's of parallel lines, but I'm not going to be that picky when it comes to proofs. That's what allows that to happen. And that's the only things that we can get on those two things. All right. Let's bridge the gap between what we did last week and this week. So we're going to get back into a little bit of algebra and tie it together with our converse theorems that we're dealing with here. So proving lines are parallel. So we're building up to doing proofs. We'll probably really hit that hard tomorrow over here. Find X so that A is parallel to B and state the converse that you use to set that up. Okay, so what do we know about this angle here and the 137? Alternate interior. Since it already says converse there beside it, I'm just gonna do that. Alternate interior angle, so what do we know about them? They're congruent to each other, so we set 10x minus 23 equals 137 and solve that equation. So 10x equals 160, x is 16. Oops. All right. 2. Corresponding. So they're congruent to one another, so 9x plus 11 equals 74. If you did it the other way, it's fine. So 9x is equal to 63. 7. Relationship there. Consecutive interiors. So they add up to be 180. So we got 6x minus 30 plus 96 equals 180. 6x plus 66 equals 180. Be 114 by 6. X is 1, 5 left of 1. 19. 19. What's the relationship on number 4? Alternate exteriors. So, yeah. 33 equals 7x plus 5. 28. 7x. X equals 4. Easy stuff, right? Yeah, y'all like this stuff. That's good. Corresponding. Which means they're what? And 3x is equal to 38. Or 36, sorry. X is 12. Consecutive exterior, good job. Which means they're what? Supplementary. 12x minus 29. 16x. Plus 28. Or yeah, and then you move the 28 over, so that'd be 208. Right. And then divide by 16. 1 time 4 13. Seven. Alternate interior, good job. So they are equal to each other. That's 21. Number 8. Corresponding. Easy enough. What do we know about them? Yeah, that's 90 degrees right there. That's what that box means.
So that'd be 4x minus 18 equals 90. And solve that. So 2. Good job. 2 more.
They are alternate cases.
Good job. So set them what? Equal to each other. 23x. Four x is equal to 20. X equal to 5. What was that? Consecutive interior. Good job. So what do we do with them? Supplementary, so this is them equal to 180. So I'm just going to go ahead and do 17x minus 7 equals 180. 17x equals 173. No, 187. So, nope. 111. So what's our answer? It's not bad. Same thing we did last week. Other direction here, we're trying to prove that lines are parallel to one another, so we don't know what they are until we know the angle relationship that's happening there. Tomorrow we'll come in, we'll finish that packet, so don't lose that, and we'll go over some proofs together. Not a lot, not anything new to learn with proofs. We learned that the stuff today. Tomorrow we'll practice some proofs together out of that packet, and then I'll give you some to practice on your own. So